All right, so let's expand on this model a bit more. So yeah, we all know that space has 3 dimensions and there's a 4th dimension of time. And if you're like me, you're like, well, where's that direction? I don't understand. Well, if you look at this model, time is going to go in all the same directions and it's going to be expanding. So that's what this model does. It gives time a direction. And we all know time has a direction. There's obviously something different between the past and the future. A lot of trolls will say that this model is obvious, which to me is a compliment. I just never seen it before. I don't understand. It seems to combine a bunch of models together. I don't understand why it's never been taught. And a lot of people say, why have I never seen this or heard of this before? Maybe it's somewhere out there, but I don't know why it's not what people talk about or teach, because it seems to put everything in place. It doesn't change any of the math. It just, the only insight really is that quantum mechanics is in the future and general relativity is in the past. So let's just look at it a different way, and that is information. Okay, so here's our now slice. Here's our Big Bang back in the past. And information is that we are expanding into the future, into whatever this is. It could be blank, there could be variables in the future, we don't know. And as the wave functions collapse happen, as we expand into it, it becomes information. And that information is gathering more and more, which is causing the universe to expand. That's how you look at it through the information. As for time dilation, for things, there's clock slowing down and length contraction and all that in special relativity. That would be on an earlier slice. If something's traveling really fast, it's going to leave a very short line through time. This is obviously going into the future. As something going slowly is going to leave a longer slice. So when you look at it, it's going to look like it took a longer. When you're looking at going really fast, it's going to be very short to travel the same distance. As for gravitational time dilation, that goes back, you need to examine the slice, and that's just going to be the same as it is in regular general relativity. And that is that a larger object is going to be more resistance to movement into the future, and it's going to be further in the past right here. This is further in the future. This is more in the back of the future, or you know what I'm trying to say. So time is going to run slowly for things over here. All right. As for turning things from classical states back to quantum states, once again, if we have this slice, here is hot, the past, the Big Bang, it's all super hot, the Big Bang, and we're getting colder and colder as we go into the future. Okay, so when we make something colder, we're moving it here. Okay, more into the future. This is the quantum world. This is GR. That's how we're making things quantum. So yeah, that goes into the same as the quantum entanglement. It's too far. We'll be back here. Quantum entanglement will be up here. Okay. So now, how does this work in 3D? It seems very obscure to put it in 3D. So let's take a slice from the side. So here's our celestial object. Here is time going that way. This is the past. This is the future. Okay. Now, this is going, the future is coming in to it, or this is moving up. That's chicken or egg. You can decide. So they all meet. Once again, this is quantum mechanics. This is GR. Okay. And all that's happening here is all the wave particle collapses as the future and the past meet. I don't know, once again, if the past is moving into it or they colliding, that's up for debate. So how does this look in 3D? Well, let's take the same celestial object, okay? And it is expanding into the future. We've all heard the saying that the Earth moves up to objects. That's how gravity works. Well, that shows how that happens. We are expanding into the future. Everything is. And the future is coming in to meet it. Like that. Future space-time, if you want to call it that. Yeah. Whether that's empty information or there's something in there, that's up for debate. And what spews out is past information, which expands the universe more and more. You can make this on a human level with a human. He's expanding, doing all the same stuff. As he expands into the future's coming in at him. The particles interact, and he reacts to it, making more information, expanding the universe even more. As for determinism, I believe that is in the realm of the Holstein problem or the incompleteness theorem, where we will never know if we can know all unless we know it all. And if the universe is infinite, then we will never know it all. So to me, the probabilities of the future are real. And the fact that the universe doesn't even know what it's going to expand into. I mean, we would need to know what was in this area, what the universe was expanding into, and how many variables were in there. Then we'd have to know the end of the universe, or the heat death, whatever you want to call it, and we'd have to backtrack. And even then, we don't know the path that things took to get there. So to me, the probabilities are real. And determinism is not. So the math holds up. The math is correct. But yeah, that's always going to be open for interpretation. So there you go.